Hi, so in this video I'll talk about TCP IP. What I'll do is I'll talk about what TCP IP is and then how the different layers communicate with each other to send data across the internet. TCP stands for Transmission Control Protocol, and what it does is specify how data is exchanged over the internet. Each layer has its own function and they are reliant on each other to make sure that data is exchanged securely and efficiently. At some point during your TCP model research, you will come across the OSI model. I will make a separate video since they are similar and different at the same time. But for now, all you need to know is that the TCP model can and does provide us with a better understanding of network communication, whereas the OSI model is more theoretical and provides us with a conceptual framework for understanding the network communication. The physical layer is the lowest layer of the TCP IP model, and it's responsible for the physical transmission of data over the network. So what does that mean? Pretty much it actually transmits raw data bits over the physical medium, so this includes things like copper wires and fiber optics. Next we have the data link layer. This layer makes sure that there is reliable communication between the two connected devices, and it's usually done through protocols like Wi-Fi or Ethernet. The link layer organizes the data sent from the physical layer from raw binary data into frames. Each frame has its own header and trailer. So what does this mean? Pretty much the header contains the source and destination address, so where the frame came from and where it's going, whereas the trailer holds all the error detection information. And this is important because it lets the receiving PC or the destination device check if the data was transmitted correctly or if there were any issues during the transmission. So next up we have the internet layer or the network layer, and it's responsible for handling the addressing, routing and forwarding of data packets across the different networks. The main protocols for this layer is IP and ICMP, and what it does is assign unique addresses to each device and then figure out what is the best path to take to make sure the data arrives efficiently and reliably. Okay, so next we have the transport layer, which is responsible for maintaining end-to-end communication across the network. So what does this mean and how does it do it? So pretty much our aim in this layer is to make sure that the two PCs or devices are communicating reliably over the network. And it does this through two main protocols, TCP, which is reliable and connection orientated, and UDP, which is faster but less reliable. There is a lot to talk about in this layer. For example, the difference between TCP and UDP, as well as how the transport layer is making sure the data is communicated reliably. So things like error checking, flow control and data segmentation. If I have made a video on this, I'll leave a link in the description so you can check it out. And then finally we have the application layer, which is actually responsible for the communication between software applications and the network. So what does this mean and how does it do it? Pretty much the applications that we use or the user uses interacts with the network through protocols like HTTP, FTP and SMTP. So each protocol that I just listed allows the application to interact with the network in its own specific way. So for example, HTTP is used for transmitting websites, whereas FTP is for transferring files and SMTP is for sending emails. You can see how each protocol has its own function, and applications use these to carry out different functions over the network. So to summarize, the TCP IP model is a networking architecture model that defines a set of protocols for devices that want to communicate over the internet. It consists of 5 layers: the physical layer, the data link layer, the internet or networking layer, the transport layer and the application layer, each of which carries out its own function and communicates with each other to make sure that communication over networks is done reliably and efficiently. Okay, so I'm going to end the video here. Hopefully that's been helpful. If you have any questions, just send me an email or leave them in the comments, and yeah, I'll see you in the next one.